Hey guys, Mr. Backberg here. In this video, we're going to look at using the quadratic formula to solve quadratic equations. Now, we've already talked about factoring as a way to solve a quadratic equation, and we've looked at the square root property, and we've looked at completing the square, but sometimes those strategies don't work very well depending on what our quadratic equation looks like. So it's going to be helpful to have this quadratic formula because the quadratic formula is going to work for any quadratic. So as we're looking at the general form of a quadratic equation, it's going to look like ax squared plus bx plus c equals 0. And the way the quadratic formula is going to work is it's going to take these a, b, and c values from our equation and use them in this formula to help us solve. So the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Now there's going to be one part of the quadratic formula that we want to pay close attention to, and that's going to be our stuff underneath the radical. So that's the b squared minus 4ac, and that's called the discriminant. And the reason we want to pay such close attention to the discriminant is it actually tells us how many solutions our equation is going to have, depending on what the discriminant looks like. So if the discriminant is positive, then there's two real number answers. But if the discriminant is 0, then there's going to be one real number answer. And if the discriminant is negative, then there's going to be two complex or imaginary answers. So let's look at an example in here. And let's say we had 6x squared minus 5x minus 4 equals 0. We're going to use the quadratic formula, but before we get to the quadratic formula, we're going to check the discriminant. So remember, the discriminant is b squared minus 4ac. So my b value is negative 5. So I'm going to take negative 5 and square it. Minus 4 times the a value is 6, and the c value is negative 4. Now 5 squared is going to be 25. And if we take negative 4 times 6 times negative 4, that's going to turn into positive 96. So if we add these together, we get 121. So because we got a positive discriminant, that means that we're going to have two solutions to our equation. So remember, the quadratic formula is negative b plus or minus the square root of that discriminant, b squared minus 4ac all over 2a. So we're going to take the opposite of our b value. So b is negative 5, so the opposite of that is positive 5, plus or minus the square root. Now we actually already did the discriminant. We got 121 as our answer. So I'm just going to fill that in underneath my radical. And this is over 2 times the a value, so 2 times 6. Now as we start simplifying this down, we're going to have 5 plus or minus. The square root of 121 is actually 11. And on bottom of the fraction, 2 times 6 is 12. Now you have to be a little bit careful because there is going to be two answers in here because of the plus and the minus. So the first thing I'm going to do is take 5 plus 11. 5 plus 11 is 16, and that's going to be over the 12. And then I'm going to take 5 minus 11, which is going to be negative 6, and put that over the 12. Now we should reduce down our fractions anytime we're able to. So 16 over 12 is reducible by 4, so I can divide top and bottom by 4. So on top, I'm going to get 4, and on bottom, I'm going to get 3. So we get 4/3 as our first answer. Over here with the negative 6 over 12, each one of those is divisible by 6. So on top, negative 6 divided by 6 is going to be negative 1, and 12 divided by 6 is 2. So here's our two solutions to this quadratic equation, 4/3 and negative 1/2. Now let's take a look at another example in here. So let's say we had 4x squared equals 8x minus 1. The first thing we should notice is that this quadratic equation is not written in that general form. It's not equal to 0. So the first thing I want to do is subtract that 8x over to the other side, and then I'm going to add the 1 over as well. So then if we rearrange this, this should be 4x squared minus 8x plus 1 equals 0. And now we're going to start working on the discriminant, so b squared minus 4ac. The b value is negative 8, so we're going to square that. Negative 8 squared minus 4 times the a value of 4 times the c value of 1. So negative 8 squared is positive 64. Negative 4 times 4 times 1 is negative 16. So the discriminant is going to be 48. So because we got a positive value, we're going to have two solutions. So as we start writing out our quadratic formula, the opposite of b, so the opposite of negative 8 is positive 8 plus or minus the square root of that discriminant, 48, all over 2 times the a value. Well, the a value is 4, so 2 times the a value is going to be 8. Now on top with that square root of 48, that's not a nice perfect square, but we can break it down. So the square root of 48 is going to split into 4 and 12. 4 splits into 2 and 2, 12 splits into 2 and 6 splits into 2 and 3. So I've got one pair of 2's that I can take out, and I've got another pair of 2's that I can take out. So we got 2 times 2, but we've got this unpaired 3 underneath the radical. So that square root of 48 is actually going to simplify down to 4 root 3. So we're going to have 8 plus or minus 4 root 3 all over 8. Now I'm going to take and split these fractions up. So I'm going to have 8 plus 4 root 3 over 8. And we'll also have 8 minus 4 root 3 all over 8. But we're going to reduce down these fractions. Now to reduce down this fraction, I'm actually going to take out a GCF. So on top, we can factor out a 4. That 8 is going to turn into a 2. And with that 4 root 3, that's just going to turn into a regular root 3. On bottom, if I factor out a 4, well, 8 is 4 times 2. So then I can cancel out this 4 in the front with this 4 on bottom. So then we're going to be left with 2 plus root 3 over 2. And if I do something similar with this other fraction, factor out a 4, then this is going to be 2 minus the square root of 3. And then again on bottom, 8 is 4 times 2. I can cancel out those 4's, so we get 2 minus root 3 over 2. So here's our two solutions this time. So I'm going to throw another example at you. Let's do 4x squared minus 12x plus 9 equals 0. Again, the first thing we want to check is the discriminant. So we're going to take our b value, so negative 12, and square it, minus 4 times the a value, which is 4, times the c value, which is 9. Now, negative 12 squared is 144. Negative 4 times 9 is negative 144. So we get a discriminant of 0, meaning that there's only going to be one solution. So if we start filling out our quadratic formula, the opposite of b, so the opposite of negative 12 is positive 12, plus or minus the square root of 0 all over 2 times a, so 2 times 4 is 8. Now the square root of 0 is just 0, so we really don't need that square root on the back end. We're really just going to have 12 over 8, but that's reducible. We can divide top and bottom by 4. So 12 divided by 4 is 3, and 8 divided by 4 is 2. So our only solution in this case is 3/2. I'm going to throw one more example at you because we haven't seen one that has imaginary solutions yet. So let's look at the equation. 9x plus 3 times x minus 1 equals negative 8. Now on the left-hand side, we're going to have to FOIL that out. So 9x times x is 9x squared. 9x times negative 1 is negative 9x. 3 times x is plus 3x, and then 3 times negative 1 is negative 3 equals negative 8. Now on the left-hand side, we're going to be able to combine this negative 9x and this 3x to get negative 6x. And I'm actually going to take that negative 8 and add it over to that 3, so that becomes a plus 5 equals 0. So if we start checking our discriminant, b squared, so negative 6 squared, minus 4 times the a value of 9 times the c value of 5. Negative 6 squared is 36. Negative 4 times 9 times 5 is negative 180. So we get negative 144 as our discriminant, meaning that there's going to be two complex or imaginary solutions. So if we start filling out the quadratic formula, the opposite of b, so the opposite of negative 6 is positive 6, plus or minus the square root of our discriminant, negative 144, all over 2 times the a value, so 2 times 9 is 18. Now the square root of negative 144 is going to be reducible. We can split this into positive 144 and negative 1. Hopefully we recognize 144 as a perfect square. That's going to be 12, but because we've got this negative 1 in there, it's going to be 12i. So it's going to be 6 plus or minus 12i over 18. Now I'm going to split these fractions up. So we're going to have 6 plus 12i over 18 and 6 minus 12i over 18. And to reduce down these fractions, I'm going to work on taking out a GCF. So on top, I can take out a 6. Then we're going to have 1 plus 2i. And on bottom, 18 is 6 times 3. So I can cancel out those 6's. So my first solution is going to be 1 plus 2i over 3. And if I do something similar, if I factor out a 6, then we're going to get 1 minus 2i over 6 times 3. Cancel those 6's again, and our second solution is 1 minus 2i over 3. That's going to be it for this video. Thanks for watching.